This is the Core 2 video for completing the square, our classwork on completing the square. We were going to do it on February 7th, but I had a substitute, so we're doing it on February 8th. Hopefully you finished the do now. Take a quick look at the do now because it's going to help us in thinking about the rest of the problem. So to start off with, make it a little bigger so we can work with it. First problem in the do now, x plus 5 times x minus 5. You'll notice one is positive, one is negative, but they're both the same number. One's positive 5, one's negative 5. When I do that in my area model, x plus 5 x minus 5, and I multiply the areas of the individual rectangles. X times x is x squared. X times 5 is 5x. Negative 5 times x is negative 5x. And I end up with negative 25. I have a square number here, perfect square number, because I have 5 and 5, but it's actually negative. I'm subtracting that perfect square number. So when I write the equation in standard form, I have x squared, and then I have 5x minus 5x. I have 5x's, but I lose 5x's. I end up with no x's. It's perfectly all right to write plus 0x. I'm going to do that later to help us factor. And then the last term is minus 25. But in my final answer, I just put in the 0x to help me think about it. If we have 0x, we don't write that. We just write x squared minus 25. And you'll notice some similar things happening with the second problem. Here again, my area model. I have x plus 7 and x plus negative 7. So I do my areas. X times x is x squared. X times 7 is 7x. Negative 7 times x is negative 7x. Negative 7 times 7 is negative 49. So once again, writing my standard form, I have x squared. 7x minus 7x is 0 x's. And then I have minus 49. And ultimately, in my final answer, I have x squared minus 49. We call that the difference of two squares, because I have x squared, and I'm subtracting 7 squared. When you see that, you know it's going to look like this. You have x minus 7 and x plus 7. You need the minus 7 and the plus 7 to get 0x. And you need the minus 7 and the plus 7 to get negative 49. Okay, so difference of two squares. You see that? You can immediately factor it this way. Generally, though, I'm going to write in the 0x to help me factor it. Helps me think about it. Let's move on to our problems. The instructions say, I will work a problem off of the A list, and then you work a problem off of the B list. You'll choose a problem similar to it on the B list. Unfortunately, I forgot to write A list and B list. So write those in if you would, please. And here again, problem number 1. Very similar to the do now. X plus 2 times x minus 2. Area model once again. And you're probably starting to realize it's going to look a lot like the problems in the do now. 2 times x is x, negative 2x, and negative 2 times 2 is negative 4. So I have a negative of a square number, and I have 2x minus 2x. I end up with x squared minus 4, because 2x minus 2x is 0x. Give you 25 seconds to find the corresponding problem on the B list. So we'll say the B list. All right. I'm looking for a number times two binomials, and I have that here. X plus 3 times x minus 3. Here I have x plus 5 times x plus 5. One's positive, one's positive. That doesn't really work for us. We want the positive and the negative. So I'm going to connect number 1 to number 3. And if you would please, work number 3. I'll give you 2 minutes to do that. Number 3, of course, on the B list. All right. Let's go back to the A list. I just did problem number 1. Now I'm going to work problem number 2. If you notice, problem number 1, we ended up with difference of 2 squares. Oh, I'm sorry. I forgot to multiply by 2. I apologize. Distribute the 2. 2x squared minus 8 is my final answer. Okay, please make that correction. Number 2, now I have a number multiplied by x squared minus another number. So I'm going to factor that. And just like I forgot to do before, I forgot to multiply in the 2. If I were factoring this, I would have to take out the 2. So I'm going to take out the 3. I'm going to call this 3 times x squared minus 25. And if I distributed that 3 I would get 3x squared, and I would get 3 times 25 is minus 75. So I'm just going backwards from distributing it. But the important thing there is that gives me the difference of two squares. I can factor this. I'm going to say 3 times, and to make it easier to factor, I'm going to say x squared plus 0x minus 25. That gives me something to work with if I draw my area model. And I don't have a lot of room here, but I'm going to draw my area model over here. A lot of you can already see I have x squared here, I have minus 25 here, and these two need to add up to 0. So I know I have x times x to get x squared, and I know I'm going to have 5 and negative 5 to get my negative 25. Negative 5x is, negative 5 times x is negative 5x. X times 5 is 5x. When I add these two together, I get 0, 0x squared. So I can say this is 3 times x plus 5 times x minus 5. That's all equal to 0. To solve this, to get the final answer, I divide both sides by 3. 0 divided by 3 is 0. So I have x plus 5 times x minus 5 equals 0. And that tells me, we need a little more room to work. Come up here, either x plus 5 equals 0 or x minus 5 equals 0. If x plus 5 equals 0, then x has to equal negative 5. If x minus 5 equals 0, then x has to equal positive 5. Either one of those two numbers, if I go back up here, negative 5 squared, negative 5 times negative 5 gives me 25. 3 times 25 is 75. 75 minus 75 is 0. If I take the positive 5 squared is still positive 25. 3 times positive 25 is 75. 75 minus 75 is 0. So those two numbers will make this equation true. So going backwards from number 1, we managed to figure out the numbers that make this 0. Take 25 seconds. Find a problem similar to that on the B list. So you're looking for a number times x squared minus a number equals 0. Find that, and then you can work on it. Okay. A number times x squared minus a number. I look up here, I have 5 times x squared minus 45. If I divide that 45 by 5, I get 9. So I would have a square number minus, or x squared minus a square number. So number 1 actually looks a lot like number 2. Try number 1, and then we'll move on. we've done number 1 on the B list. We'll go back over to the A list. We've done 1 and we've done 2. And you notice that 2 is kind of backwards from number 1. So number 1 kind of helped us figure out how to do number 2. Number 3 is going to be the same way. I have to multiply 2 binomials. We've done this before. Start with the area model. The interesting thing about these is that I have x plus 3 times x plus 3. And this is actually x plus 3 squared. But that doesn't help me in multiplying it together. Now I want to see what it looks like after I multiply it together. So x plus 3 and x plus 3 for my area model. X times x is x squared. 3 times x is 3x. 3 times x is 3x. And 3 times 3 is 9. So I end up with a perfect square number here. And I have to add the 2 of the 3's together. So I end up with 2 times 3. And I'm going to write it that way just to emphasize that. I end up with x squared plus 2 times 3x plus 3 squared. 3 times 2, 3 squared. Ultimately, though, for my final answer, I write x squared plus 6x plus 9. I did this just so you can think about it. We're going to use that in the other problems. But right now, my answer is this. And when you see this, I want you to see 2 times 3, 3 squared. Okay. 25 seconds. Find a problem similar to this one on the list, and we'll get started. Okay, so 2 binomials multiplied together. Here I had 2 binomials. One was positive, one was negative, but I want 2 positives. So I find that in number 4. So I connect number 3 to number 4. And I want you guys to work on number 5. I'm sorry, number 4. We connected number 3 to number 4. So work on number 4, if you would, please. Keeping in mind that this is actually x plus 5 squared. Okay. Now that you've done problem number 4, let's go back and work another problem off of the A list. And we're on number 4 on the A list. So here we multiplied two binomials. We actually squared a binomial because we multiplied a binomial by itself. Here I'm going to factor that binomial and use that to solve the equation. So to factor, first of all, area model. I know I have x squared, and I know I have 16. So I need two x's to get the x squared. That's easy enough. I need to add these two numbers to get 8. Or, I'm sorry, add these two numbers to get 8, because I'll have this number times x, this number times x. And I multiply them to get 16. And thinking off the top of my head, 4 times 4 gives me 16, and 4 plus 4 gives me 8. So I have 4 and 4, 4x and 4x. Add these two together, I get 8x, I get 16, and I get x squared. So I know this is x plus 4 times x plus 4. I'll write that. You probably won't want to after today, and it all equals 9. To solve this, I'm going to call this now actually x plus 4 squared. Equals 9. I take the square root of both sides. X plus 4 equals 3. Or x plus 4 equals negative 3. If my answer here is negative 3, when I take negative 3 times negative 3, I'll get positive 9. So that negative 3 works just as well as the positive 3 as far as this equation is concerned. When you take the square root on your calculator, though, it always gives you the positive number. It will always give you this number. You have to remember, this number squared will give you 9 also. There are two ways to square a number and get 9. So x plus 4, I subtract 4 from both sides. Or, again, I subtract 4 from both sides. But now I subtract 4 from negative 3. X equals negative 7. So there are two x's that I can put back in here and get this equation equal to 9. That is my final answer. Okay. I was able to solve this because I had a perfect square binomial. I could take this, I could take my equation and factor it into two binomials multiplied. They happen to be the same, so I could call that squared. X plus 4 squared. That allows me to take the square root of both sides. So it's going to give you 25 seconds to find the corresponding problem, but there's only one left. You will notice that number 4 is kind of the same as number 2. So take a minute to look at number 2. Sorry, take 2 minutes and work number 2. Don't just look at it, work it. Okay. So we've done problems 1 through 4 on the front side. Let's go on to the back side. I will start a new video for the back side. Turn your papers over.